Question 1, in a particular population, 15% of the people are left-footed. Soccer team of 11 players, including one keeper, is picked at random from the population. A is asking us to find the probability that exactly one left-footed player from the team. Give your answer correct to 3 decimal places. So let's just write down what we know here. So we have left-footed, which is a probability of 15%, which is the same as 0.15 as a decimal. So if I divide 15 divided by 100, I get 0.15. And that means then that a right-footed, the probability of being right-footed, is 1 minus 0.15, which is 0.85. So that's the probability of being left-footed and right-footed. In this question, I'm going to use my binomial distribution here to answer this question, which is given as n choose or, n being the number of trials, or mean the number of success, times p, which is the probability of success, and we'll go through all these now in a second, multiplied by q, which is the probability of failure, and that is to the power of n minus r. So let's fill that in and see what we have. So n is the number of trials. So how many times are we doing this? Well, I'm only picking one person. So it's going to be 1 choose 1. And the probability of success or being left-footed is 0.15, and that's going to be to the power of 1. And I'm multiplying that then by the probability of failure, which is being right-footed, which is 0.85. And that is going to be, my n is 11. Sorry, I have 11 players on the team, not 1. And I'm multiplying the 0.85 to the power of n minus r, which is 11 minus my 1, which is to the power of 10. And when I type that into my calculator, I get 0.3248. And they wanted the 3 decimal points, so 0.325 is the probability. Having a look now at part B, find the probability that less than 3 players on the team are left-footed. So think about this. So less than 3 players being left-footed could mean that none of them are left-footed. So I'm going to look now for the probability of none of them being left-footed. Or it could be the probability that only one of them is left-footed. Or I could have the probability of 2 of them being left-footed. Now it says less than 3, so I don't include the probability of 3. So let's go off and find the probability of these 3 outcomes. So the probability of no one being left-footed, again I'm using my binomial distribution, same as above, 11 players on the team, none of them being left-footed, so 11 choose 0, and 0.15 is the probability of being left-footed, which is success, to the power of 0. And I'm multiplying that by 0.85 to the power of 10, or 11 minus 0, which is 11. Now, I could have just done 0.85 to the power of 11, but I'm going to be consistent here using my binomial, so that's why I'm doing it out. And I get 0.1673 on my calculator. Okay, next one I'm going to do now is, so that's the probability of no one being left-footed. Now I'm going to find the probability of just one left-footed. So the probability of 1 is going to be 11 choose 1. Now actually I have this from up above, don't we? We have this answer from part A, so why make work for ourselves here? So I'm just going to rub that out, and I'm going to take my answer from part A. So from A, my answer there was 0.325. Okay, so saves me doing it out again. And my third one, probability of 2 of them being left-footed. So probability of 2 is going to be 11 choose 2, and probability of being left-footed is 0.15 to the power of 2 times 0.85 to the power of 11 minus 2, which is 9, and on my calculator that evaluates as 0.2866. I then add those 3 because or in probability means to add. So when I add them together, I'm getting 0.7789. And the question again wants it to 2 decimal points this time. So that is equal to 0.78. So that's the probability of less than 3 players on the team being left-footed. And question 1c, the goalkeeper is left-footed. Find the probability that at least 8 of the remaining are also right-footed, or sorry, are right-footed. So what have we here? So don't forget we've 11 on the team and the goalkeeper is left-footed. So that means we have a remainder of 10 players. So let's just state that. And what's happening with these 10? At least 8 of them are right-footed. So at least 8 of them means basically I could have 8 of them being right-footed, or I could have 9 of them being right-footed, or I could have 10 of them being right-footed. So that's what that is basically stating. At least 8 of them are right-footed. So I could have 8, 9, or 10. So I'm basically just going to find the probabilities of those. So I'm going to have the probability of 8 being right-footed, or meaning to add in probability, the probability of 9, or again means to add the probability of 10 being right-footed. So I just need to go off and find those probabilities. So let's do each one out separately. So the probability of 8 of them being right-footed is going to be, again, we've removed the goalkeeper, so it's not out of 11 now, it's out of 10. So it's 10 choose 8, and then my success this time is to be right-footed. So I'm going to go 0.85 to the power of 8 because I want to be getting right-footed players. Times then my failure, which is left-footed, and that's to the power of 10 minus 8, which is 2. And on my calculator, I'm getting 0.2759 for that. Probability of 9 of them being right-footed is 10 choose 9, and the success is 0.85 to the power of 9 times left-footed, and that's going to be 10 minus 9, which is to the power of 1, and that's giving me 0.3474 when I multiply that out. And just if you're doubtful, we're using the NCOR button on our calculator here, the choose button. And finally, probability of 10 being right-footed is 10 choose 10. Again, you don't have to use this method because we could just put it 0.85 to the power of 10, but I'm going to use my binomial, and my failure is left-footed, and none of them in this case are left-footed because I have 10 of them and I want to pick 10 right-foots, and that is giving me 0.1969. And I want to add them together, so I add my 3 probabilities and I get 0.8202, and the question here wants it to 2 decimal points, so therefore my final probability is 0.82, or 82% of them would be at least right-footed if there's 8 of them. At least 8 of them would be right-footed. Okay, moving on, question 2. Question 2a, the line 3x minus 6y plus 2 equals 0 contains this point where k is an element of the real numbers. Find the value of k. So we're kind of linking this here where it says contains the point. So if a point is on a line or on any curve, we know when we sub it in, it should satisfy it, or it should equal to 0. So all I'm going to do here is basically sub in my point, k for x, and 2k plus 2 over 3 for my y. So I'm subbing it in, and I should get equal to 0 when I solve it. So let's go with that. So 3 times my k, which is my x value, minus 6 times y, and my y in this case is 2k plus 2 over 3. And I'm going to then add my plus 2 and let that equal to 0. So I'm going to solve this now. So multiplying in 3 into the k gives me 3k. And then multiplying in this fraction. So think of the 6 as being over 1. And when I multiply fractions, it's top by top, bottom by bottom. So if I multiply the top, I'm going to get 6 times my 2k is minus 12k. And minus 6 times positive 2 gives me minus 12. So just watch the minus there. And on the bottom, when I multiply it in, I get 1 times 3, which is 3. Now the minus there with that 6 either goes to the top or the bottom of the fraction, but not both. So just watch out for that. And then I add on my plus 2 equals to 0. And now I'm basically going to, well actually I can divide that 3. That 3 will divide into the 12. 4 times, so I have 3k minus 4k, and the 3 will divide into this minus 12 minus 4 times. Okay, so that's making it a bit easier for me. And then I put in my plus 2 again, so plus 2 is equal to 0. Then I group them. Minus 4k plus 3k is minus 1k. Minus 4 plus 2 is minus 2 is equal to 0. If I add 2 to both sides or move over to minus 2, I get minus 1k is equal to positive 2. So dividing both sides by minus 1, I get k is equal to negative 2. Okay, so that's not too bad. Part B, the point P is on the line. The point P is also a distance of 1 unit from the line 4x plus 3y plus 6 is equal to 0. Find a value of S and the corresponding value of T. So let's see what this would look like if I was to sketch it. So I have a point P on this line x minus 2y minus 8 equals 0. And P is on that line. The point P is also a distance of 1 unit from another line, and I'm going to just sketch that other line in grey here, and it's 1 unit away from it, and I'm going to take that as the shortest distance. So the shortest distance would make 90 degrees there, and it's 1 unit away from the line 4x plus 3y plus 6 is equal to 0. Now what they're telling me is that the point P, which is this line, this point here in red, is ST. Now once again, it's similar to part A. If that point is on the line x minus 2y minus 8 equals 0, I'm going to satisfy that by subbing in S and T for x and y. So that's the first thing I'm going to do, just to verify the point sits on the line. So I'm taking the line x minus 2y minus 8 is equal to 0, and the point P, which is ST, is on the line. So I'm basically going to sub S in for x and T in for y. So that's giving me S minus 2t minus 8 is equal to 0. Now that's the same as going S is equal to positive 2t plus 8. And we will need that in a second, I think, if we're going to get the distance now to the other line. So let's think about this. So the grey line, 4x plus 3y plus 6 is equal to 0, is 1 unit away from the point ST. Now on my picture, remember that we marked these in as 90-degree angles. So the shortest distance from a point to a line is by using the perpendicular distance. And that's our formula from our log tables, which is the perpendicular distance formula, which is written as ax1 plus by1 plus c, and then the modulus brackets, all over a squared plus b squared. And that'll give me the shortest distance. And if I sub in my information, my a is the coefficient of the x, the b is the positive 3, and the c is the constant, which is the plus 6. And x1 is the s, and my y1 is my t. So I'm basically subbing them into the formula now. So it's going to give me, so let's just draw our brackets here. It's always good to use brackets, particularly when there's negative signs, but I think we're okay in this case, but let's do it anyway. All over the square root of a squared plus b squared. So filling it in, my a is 4, my x1 is s, my b is 3, and my y1 is t. And then I'm going to go plus my c, which is 6, all over 4 squared plus 3 squared. And when I multiply that out, I get 4s plus 3t plus 6 in my modulus bracket, all over the square root of 25, which is 5. Now don't forget, this is equal to my distance, my shortest distance, but they tell me in the question that the distance is 1 unit. So I'm letting this equal to 1. And what I'm then going to do is I'm going to put that 1 over 1, make it a fraction. So if a fraction equals to a fraction, quick way of doing fractions equal to fractions is when they're equal, instead of going off and getting my common denominator is 5. So if I cross multiply, let's just move it up here, I get the modulus of 4s plus 3t plus 6 is equal to 5 times 1, which is equal to 5. And what I'm now going to do is, because I have it in terms of two variables, s and t, I'm actually going to take this piece of information I have over here. Remember we said that s is equal to 2t plus 8. So I'm actually going to take that and sub it in here for my s. So that's my next step. So I'm going to say let s is equal to 2t plus 8. And when I sub that in, I get 4 times 2t plus 8 plus 3t. And now I basically have it in terms of one variable, which makes it a lot easier to solve. So I have, what does that solve out as? 8t, 4 8s are 32, add that 6 gives me 38, plus the 3t equals 5, which is giving me 11t plus 38 is equal to 5. Now we're basically going to come to these brackets, these modulus brackets. Remember what they mean. They mean that we turn our answer to positive. So this question could be, so we have two solutions, 11t plus 38 is equal to 5, or it could have given me a negative 5, 11t plus 38 is equal to negative 5. So it could be positive or negative. And when we solve that, again here I'm going to subtract 38 from both sides, will give me 11t is equal to 5 minus 38, which is minus 33, is equal to 11t. So t is equal to minus 33 divided by 11, both sides by 11, gives me t is equal to minus 3. Now I can have two values, so on the other side, I can also subtract 38 from both sides here, which would give me 11t is equal to minus 5 minus 38, which is 11t is equal to minus 43. So that gives me t is equal to minus 43 over 11 when I divide both sides by 11. So we've found t, but the question says find a value of s and the corresponding value for t. Now I'm doing it out twice here. You can see I'm finding both values for t, but they only asked for a value for s and its corresponding t. But look, I'm going to do both. So we now have to find the corresponding s. So let's see. So now find s. So when I come back to my s, we know that s is equal to 2t plus 8. And I'm going to sub in my value for t, which in this case is minus 3. And that's giving me a value for s, which is minus 9 plus 8, which is giving me s as equal to minus 1. So my value for s and t in this case are, so therefore s is equal to minus 1 and t is equal to minus 3. Sorry, I've made a mistake there on that. That should be a 2, shouldn't it? What am I doing? So that's a 2, which gives me minus 6 plus 8, and minus 6 plus 8 is 2. So my s there is positive 2. Sorry, my fault on that one. So s is 2, t as minus 3. And coming over to the second possible solution, so we'll say now find s. So I have s is equal to 2t plus 8. Which would be 2 times minus 43 over 11 plus 8. And when I put that into my calculator, I get s is equal to 2 over 11. So therefore, I could have s is equal to 2 over 11 and t is equal to minus 43 over 11. Okay, so that's part B done. We're now going to have a look at the final part to it, part C. The point A and C are vertices, so corners, of the triangle ABC as shown. D and D are points on CA and CB respectively. The ratio AD is to DC is 2:1. So they want us to find the distance from A to D. So they want us to get the length of this line here. Well, basically what I'm going to do is, I'm going to get the distance from A to C first of all. And then I'm going to use the ratio here to split that length AC in the ratio of 2:1, which will get me then the distance from A is to D. Because it is in the ratio 2:1. So using my log tables, my distance formula is given as x2 minus x1 all to be squared plus y2 minus y1 all to be squared, and that's in our square root. So that's coming from my log tables. And the distance I'm getting is between A, which is 4, 2, and C, which is 16, 11. And labeling those 2 points, x1, y1, x2, y2, and subbing them into my distance formula now. So distance between A and C is x2, which is 16, minus x1, which is 4, squaring that, plus y2 minus y1, squaring that, and then getting the square root of that value. So my distance from A to C, so let's now call it A to C, is 12 squared plus 9 squared, which is giving me, what's that giving me? 144, isn't it? Plus 81, all to be square rooted. Bringing that up then gives me a distance from A to C as square root of 225, which is 15. So the distance from A to C is 15 units. Now it's split then in the ratio of 2 is to 1. And to get the ratio then you add the ratio. So 2 plus 1 is 3. And basically then A to D is going to be 2/3 the length of the line AC. So it's 2/3 of AC. So basically I'm just taking 15 dividing by 3 multiplying by 2, or 15 multiplied by 2 over 3, which is 10 units in length. Now you could also use your ratio formula from your log tables. But I think using the distance formula is a little bit easier. Coming down now to part 2 of part C. So AB and DE are horizontal line segments. AB is 33 units in length. Find the coordinates of B and E. So what I'm going to do here is I'm going to use knowledge of similar triangles here. So let's sketch out what we know. So we have the smaller triangle CDE. So that's the smaller triangle, and let's fill in what we know. 16, 11 is the coordinate. We then have the larger triangle, the full triangle. Again, these aren't to scale, but it's just to kind of visualize it. And I have the C coordinate as 16, 11 at the top again. And I have A, bottom left, vertex A as 4, 2. And the other vertex B. And that's what I actually need to find. I need to find B, don't we? So let's start with B, as I say. I'll come to E then in a couple of minutes. So let's fill in some information onto our diagram. We know the distance from A to B is 33 units. So that's given in the question. We also know from part 1 up above that the distance from A to C is 15 units. So we're going to write that in. And we also know that the distance from A to D would be about here, is 10 units. Now again, this isn't to scale. So that means the distance from D to C is 5 units. I'm going to write that on my smaller triangle. So let's kind of use a little bit of basic knowledge here. Using similar triangles, how have I gone from 15 to the 5? So in order to get from 15 to 5, I'm dividing by 3. So if I want to go from 33 to this length, it means I have to divide 33 by 3, which gives me a length of 11 units. So that's a little bit of information that we know. So let's see, can we figure out anything else here now? The coordinates of A are 4, 2. Now this is a horizontal line, so that means then that the y coordinate there does not change. So in my coordinate B, my x must be 2. Because it's a horizontal line, think of it, it's just sliding across from left to right. But now we have to find the x part. In A, it's 4, 2. But basically what's happening here is I'm going 33 units along that horizontal line. So to get the value of the x, I'm at 4 when I'm at A, and I need to add on 33, which brings me to 37. So the coordinate B is actually going to be 37, 2. So that's finding the coordinate of B, just by using a bit of simple mathematics, playing around with the similar triangles. Let's have a look now at finding the coordinate E. So what I'm first of all going to do is I'm going to sketch out the diagram from up above so we can mark in on it. Okay, so it just makes it a little bit easier rather than scrolling up and down. And what else do we know on the picture there? We know that B is 37, 2. Is something else we know. Okay, that's about it. So let's have a look at it here. So we're trying to find the coordinates of E now. And if you think about this here, if we focus in on the y coordinate here, if we want to find y, if we focus in on the y of the C and on the B as well. So remember that this is like in XY axis. This is a coordinate graph basically. So we're basically getting the distance from here at the top of C all the way down to this line here, AB. So that distance there is between 11 units high on the x-axis and 2 units high. So basically what I'm doing there is, if I take 11 minus 2, I get 9 units. So basically what that's telling me is that the distance from AB to the vertex C, if I was to go perpendicular height, would be 9 units in height. Now, again, the ratio here is, it's split into ratio 2 is to 1, which is giving me 2 plus 1 is 3. So basically, the distance from E to C will be 1/3 the length of that 9 units. So if I get 1/3 of 9 units, I'm getting 3 units. So basically all I want to do is, I basically want to start at C and go back 1/3 the length of that line, which is 3 units in other words. So I'm going back 3 units. So if I go 11 subtract 3, so therefore 11 subtract 3 will give me 8 as my y. So my E is starting off as xy, so x8 in other words. So that's the y coordinate found. Now I need to find the x, and I'm going to tackle it in the same approach. What I'm going to do here now is, if we look on the horizontal axis, so I'm going from, let's say I'm going from C. So again, let's draw a line down. So I'm going from here all the way to B. So there are two distances that I know. So what's the distance there going to be? Well, the x is 16 minus from the 37. Actually, let's go the other way. So 37 subtract the 16, which is giving me 21. So the distance from C to B on the horizontal is going to be 21 units. Now it's the same again. I'm looking at 1/3 of that. So let's write that over here actually in the box. Kind of stuck for space here in this. Now there's different ways you could do this. This is just the way I'm spotting it through, a little bit of problem solving here. So that's 21 units. And I want to find 1/3 of that. So 21 multiplied by 1/3 is equal to 7 units. Now what do I want to do with the 7 units? Think about this now. What way are we going? So I'm starting at 16 and I want to come over 7 units because it's going in the positive direction. So I need to add on 7 to 16. So therefore 16 plus 7 is bringing me up to 23. So my y is going to be 23. So filling all that information in now, I have B as 37.2 and I have my E as, I've lost it now, 23.8. So looking at question 3, so the information we're going to take from this is that the length of the line segment AB is 4√5, so that's that length of a line here. And what's the question asking us? It's asking us to find the length of the radius K. So they're getting us to find the length of the radius of that circle. What I'm going to draw in on my circle is the radius length, and I'm going to draw it from the point C, which is the center, out to the edge of the circle, and I'm going to connect it to A. Now we could connect it to B if we wanted to, but that's basically what they're asking us to find, the length of the radius line. You can see there that I've basically created a triangle. The angle here where we have our radius line meeting our chord is always a 90-degree angle. And another piece of information we know about a chord is that when it hits the radius, it divides the chord in 2 equal halves. So that point D is basically the midpoint of the line segment AB. So I'm going to draw out that triangle. So we're going from point A to point C. So there's a lot of information there, but hopefully we can figure all that out. And we're going over to the point D. And the distance from A to D is half the length of AB. So that's going to be 4√3 divided by 2, which is 2√3. I've created a 90-degree angle. And what's the distance from C to D? Well, I don't know that actually, so I might go off and find this length here in 1 second, the distance from C to D. And what are we asked to find? We're asked to find the length of the radius, which is this length of a line here, and I'm going to call that R for radius. So I'm going to hopefully use Pythagoras' theorem in a couple of minutes, but before I use Pythagoras' theorem, I need that other length CD. So I'm going to go off and find that using my distance formula. So from my log tables, I have the distance as x2 minus x1 all to be squared plus y2 minus y1 all to be squared in the square root. I'm getting the distance from A to D, and I have the point, C to D, I should say, and the point C is 1 minus 2, and the coordinate of D is 3, 2. And labeling those as my x1, y1, x2, y2, and filling them in then to my distance formula, I have 3 subtract 1 to be squared plus y2 minus y1 all to be squared in my square root. 3 take away 1 is 2, 2 squared is 4, 2 minus minus becomes 2 plus 2 is 4, 4 squared is 16. So the distance from D to C is giving me a square root of 20, which is the same as 2 root 5. So I'm going to come back up to my little sketch here and I'm going to write that in. So I have 2 root 5 here for the distance from C to D. Now I can actually find the length of my radius line using Pythagoras' theorem. My formula for Pythagoras is c squared is equal to a squared plus b squared. C squared must be the hypotenuse, the side across from the 90, so that's going to be my radius. My A and my B are the other two sides, so it doesn't matter which is your A, which is your B. I'm calling the distance from A to D my A, so that's 2 root 3 all to be squared plus 2 root 5 all to be squared. So that's getting me a radius squared of 4 times 3, which is 12, 4 times 5, which is 20, which is 32. So R is going to be the square root of 32, which is 4 root 2. And if you could scroll back up to the top of the question, it said give your answer in the form A root B. And that's what we've just done. We have it as 4 root 2. Okay, scrolling down now to part B. So B part 1 is asking us to show that the circle C and the circle S touch externally. So it basically looks something like this. So if we do a quick sketch of what's going on here, and if they touch externally, it basically means that if I get the distance from the edge of the circle to the radius for one of my circles, let's call that C, and I get the distance from the edge of the circle to the center of my other circle S, that is the same distance as me getting the distance from point to point, center to center. So we basically know it so as to prove touching externally, we add our 2 radius, or 1 plus R2, and that must give me the distance between the two centers. And if it does, well then they're touching externally. We subtract them then if it's touching internally. So what do we know here? So our first circle, S. So the center of S, let's write down some information here. So the center of the circle S, first of all, is going to be 7, 13. Okay, so we can just read that from the equation of the circle there. And my radius of S is going to be root 25, which is 5. So there's my center and my radius of S. Let's come over now and do the same thing for circle C. So my center of C, now we need our log tables for this. So I have 2g is equal to 4, isn't it? It is, yeah, the coefficient of the x. So 2g is equal to 4. G is equal to 4 divided by 2. G is equal to 2. So minus g is equal to minus 2. And then I need to have my f. So 2f is equal to negative 2, the coefficient of the y. So that's minus 2. F is equal to minus 2 divided by 2. F is equal to minus 1. Minus f is equal to positive 1. So that means then that the center of C is given as -2, 1. And now I need to get the radius of C. So radius of circle C. And again, it's given by the log tables formula, g squared plus f squared minus c squared. And I plug in my values for g and f, and I put in -2 squared. Make sure we use brackets here because they're negative. And minus my c. My c is the constant, which is -95. So that's giving me minus 95, isn't it? It is, yeah. So I need to put in my 2 minuses there. So that's giving me 4 plus 1 plus 95, which is the square root of 100, which is 10. So the radius of C is 10. Kind of stuck for space here. Let's make a bit of room. So that is the 2 radius. What I now need to do is get the distance between the 2 points. So I'm going to get the distance between the centers. So the centers here again are 7, 13 and -2, 1. And I'm going to label them then x1, y1, x2, y2. Putting them then into my distance formula, x2 minus x1 all to be squared plus y2 minus y1 all to be squared in the square root. And that's getting me the distance between the 2 radii. And putting in my values, I have -2 minus 7 all to be squared plus y2, which is 1 minus 13 all to be squared. Running out of space here, so let's see what that gives us. That gives us the square root of 225, which is a distance of 15 units. So if we come back to the top here, how do we prove that they touch externally? I'm going over here now. It's r1 plus r2 is equal to the distance. My radius 1 is 5, so that's my first value. My radius 2 is 10, and I put that in. That should equal to the distance between the 2 points, which is 15, and it does. 5 plus 10 is 15 is equal to 15, which is therefore touching externally. Okay, not a lot of space there. Scrolling down now to part 2, B part 2. So there are infinite number of circles which touch circle C externally at the same point that S touches C. Find the coordinates of the circle of any of the, the coordinates of the center of any of these circles apart from the circle S. So there's infinite amount of circles we can have. Different ways we can do this question. First of all, though, let's kind of just sketch what we have just so we can visualize what they're asking us to do. So I've just sketched out my coordinate graph, and now I'm going to draw the circle C. And C has a center of -2, 1 and a radius of 10. So what would that look like on my graph here? So I go back -2 up to 1. So there's my center, radius of 10. So I go up 10. Brings me to 11, go back 10, brings me to back here, let's say -12, go forward 10 is bringing me up to 8, and down 10 is bringing me to 9, so somewhere down here. And if I was to sketch that then with my circle, very rough here, it's going to look something like that. Okay, well, let's just park it there for a second. My other circle is the circle S, and let's see what's happening with S. S has the center 7, 13 and a radius of 5, wasn't it? It was. Okay, so let's see where that will go on my coordinate graph. So I have my center 7, 13, which is about there, and a radius of 5, so that brings me down to about 8, which is there. 7 take away 5 brings me to 2, which is about there, and 5 to 12 is there. Okay, so again, it looks something like, and all I'm trying to get to do here is just where they, okay, that's not it, where they basically touch the circle. And again, it's just a rough sketch here. All I'm trying to do is get that coordinate here. And all I want to do is visualize that. And that's the point where the circle C and the circle S are meeting. So this is just a very rough sketch so I can visualize this. And they want me now to find the equation of any other circle that goes through that point. So just zooming out for a second. So basically another circle could be this one. Or it could be this one. Again, just very rough sketches, but that's what they're asking us to find. Now, what I want you to visualize there is that both of these centers are going through a line. So if I draw a line between the two centers of these circles, see that green line here? Now, those two centers also go through that point of contact. And remember that we know that the distance from the center to the edge of the first circle is 10, and the distance from the edge of the circle to the other center is 5. So that's the 15 that we got in B part 1. And what I know though is that any other circle will also have a center that is on that green line. So basically what I want to do is find the center of a circle that basically sits on this green line. And in order to do that, or how to find that coordinate, what I'm going to do is I'm going to get the equation now of this green line using my two centers. That's the first thing I'm going to do. And then separately, so let's just highlight that actually. So I'm going to get the equation of this yellow line between the two centers. Separately then, I'm going to get the equation of the tangent, which also goes through that point. And I'm going to use simultaneous equations to find that point in blue. So that's what I'm going to do next. So first of all, let's find the equation of that yellow line. So I'm using the two centers, -2, +1, and 7, 13. Labeling those x1, y1, x2, y2, using my slope formula for my log tables. And subbing that in, I get 13 subtract 1, 7 minus -2, which is giving me a slope of 4/3. So that's the slope of the line between the two centers. And now I'm going to form the equation of the line. So my y minus y1 equals mx minus x1. And I can use either one of the 2 points as my x1 and y1. So I'm going to sub in the 1 as my y1, and I'm subbing in -2 as my x1. And then if I multiply across by 3, that's giving me 3y minus 3 is equal to 4 times x plus 2, which gives me 3y minus 3 is equal to 4x plus 8, which tidies up as 4x minus 3y plus 11 equals to 0. So that's the equation of the line between the two centers. Now what I want to do is I want to find the equation of the line that goes between the two circles, so the tangent to the point of contact. So in other words, the equation of this blue line. And in order to get the equation of a tangent between the two circles, basically what I want to do is I subtract the two equations of the circles from each other. So that's what I'm going to do now. So I know the equation of one of the circles is x squared plus y squared plus 4x minus 2y minus 95 is equal to 0. The other equation is in the form of x minus 7 squared plus y minus 13 squared equals 25. When I multiply that out, I'm getting x squared plus y squared minus 14x minus 26y plus 193. So I'm basically just squaring out the brackets. And then if I subtract them from each other, or multiply across by -1, basically changes these signs. My equation of the common tangent is then giving me, well, they'll cancel, 18x plus 24y minus 288 equals to 0. So that's the equation of that blue line. So let's just highlight what we have. That's the equation of the blue line. That's the equation of the yellow line. Now I want to find out where they intersect with each other. So I'm going to use simultaneous equations to find the point of contact. So I'm going 18x plus 24y is equal to 288. Simultaneous equations with 4x minus 3y is equal to -11. Multiplying the bottom by 8 is giving me 18x plus 24y is equal to 288. And on the bottom now, when I've multiplied by 8, is 32x minus 24y is equal to minus 88. The positive 24y and the negative 24y will cancel. 18 plus 32 is 50x is equal to 200. So that means that x is equal to 4. Now I don't actually have to solve for y, because let me show you on the picture. The 4 that we found is basically here. So if I draw that line up again, this is only a sketch, so it's here. Let's draw a bigger point. I've basically just found the 4 there. Now we don't need the y, because all I need to do is that the point that I pick must have an x value greater than 4. Because if I use anything less than 4, I'm basically coming back inside the circle C. So my value for x in my equation of the new circle must be bigger than 4. Okay, so that's why we did out the simultaneous equations, just to get that value of 4. So basically what that basically means now is that if x has to be bigger than 4, I can look for the equation of any circle now. So I'm just going to assume, so let x equals to 6, as long as it's bigger than 4. And if x is bigger than 4 and I'm letting it equal to 6, I basically need to find its corresponding y value. Again, remember, it must sit on the line 4x minus 3y plus 11. That's the equation of the circle between the two centres. So if I sub in x as 6, I should solve for y. So I'm subbing in 6, so 4 bracket 6 minus 3y plus 11 is equal to 0. And I get minus 3y, 6, 12, 18, 24, 35 equals to 0. So minus 3y is equal to negative 35. So in order to solve for y then is equal to minus 35 divided by minus 3. Minus divided by minus is positive 3 into 35, just stays as 35 over 3. So therefore, one sample coordinate for the center of a circle is x as 6, I should say, as long as I pick it bigger than 4. So I picked 6, and y as 35 over 3. So different ways of doing that question, but all will have an x value bigger than 4, and that's why I did all that complicated bit of work at the start to make sure that that value is true. So question 4a, part 1, prove that cos 2a is equal to cos squared a minus sine squared a. So we're going to need our log tables here for this. And in order to solve this or prove this, I'm going to use page 14 in my log table. So it's handy to have them in front of you so you know where the information is coming from. So on page 14 in the log tables, in order to solve this, I'm going to use cos A plus B. So this is the compound angle up the top left-hand corner of the log tables, is equal to cos A cos B minus sine A sine B. So that's what I'm going to use here. Now think about this for a second. If we were to look at what they're asking us, cos 2a. Now 2a is the same as me just going a plus a. So that's the same thing. Sorry, I'm putting in a b, but it should be a plus a. So 2a is the same as a plus a. So think about like 2 5s is the same as 5 plus 5. It's 10. So that's the logic I'm using here. So if I use that here now, and all I'm going to do basically is I'm going to sub in capital A for A. Again, I'm using this part here, and I'm going to sub in capital A for B because I'm going for 2 times A. So that's just going to give me basically cos, subbing in A, cos A, subbing in A for B just gives me cos A again, minus sine A, and then I sub in A for sine B. And when I multiply cos A by cos A, I got cos squared A. And when I multiply sine A by sine A, I get sine squared A. That's basically what they wanted us to prove. So that's cos A plus A, which is the same as cos of 2A. And that's it. It's simply put as that. Having a look at A part 2, sine theta over 2 is equal to 1 over the root of 5, where theta, which is the angle, is between 0 and pi. So pi here in this case is radians, 180 degrees. So it's important here that they're not allowing us to solve this in any way we want. It's asking us that we must use the formula cos 2a is equal to cos squared A minus sine squared A to find the value of cos theta. So we have to use that. So like we said, we must use cos 2A is equal to cos squared A minus sine squared A. Now the question is talking in terms of theta, so I'm just going to change my A there to a theta. So I'm looking at cos 2 theta equals cos squared theta minus sine squared theta. So that's the first thing I'm going to do. The next thing is that you can look at our angle here. Our angle is actually theta over 2, not theta. So let's have a look at how can we change our cos 2 theta. So that's the same as, instead of going, well, we know that cos 2 theta is cos theta plus theta. But my angle in this case is not theta, it's theta over 2. So if we look at it this way, I'm kind of working backwards here. So that's the same as cos 1 theta, which is basically cos theta. So I'm not working now with cos 2 theta, I'm working with cos 1 theta, or just cos theta. And that's now going to give me cos squared theta over 2, or a half theta, minus sine squared theta over 2. So that's basically where I'm going from here. Now what I'm going to look at is I'm going to use my knowledge of page 13 actually in my log tables. And from page 13 we know that sine squared A plus cos squared A is equal to 1. Now my angle in this case is theta over 2, so let's just change that. It's sine squared theta over 2 plus cos squared theta over 2 equals to 1. I'm just changing my angle basically. Now what I want to do is I'm going to basically write that if we were to subtract sine squared theta from both sides, or in other words moving it over, I would get cos squared theta over 2 is equal to 1 minus sine squared theta over 2. So what I'm going to do now is I'm going to substitute in 1 minus sine squared theta over 2 for cos theta over 2. So now I have cos theta is equal to, and instead of calling it cos squared theta over 2, I'm actually going to call it 1 minus sine squared theta over 2. Subtract sine squared theta over 2. Taking that out of the bracket gives me cos theta is equal to 1 minus sine squared theta over 2 minus sine squared theta over 2. And the reason I'm doing that is, again, just actually, if you're thinking, why did I move the sine over to the right hand side? If you think about at the question here, it's asking us to find the value of sine theta over 2. So I'm thinking in my head, okay, my answer must have sine in it, and that's why I wanted to eliminate the cos. So just if you're kind of thinking which one I moved, that's the logic behind that. So now I have cos theta is equal to 1. Well, I have two of these now. So minus sine squared theta minus sine squared theta gives me minus 2 sine squared theta over 2. So think of that like sine squared theta over 2 as an x. So it's minus x is minus 2x. So just try and think of it like that. And where can I go from there? Think about up at the top of the question here. We know, so let's just box off some of this rough work here. So that's my first part. That was for in here. The next thing I know from the top of the question, this part, I know that sine theta over 2 has a value of 1 over root 5. That's what they're telling us. So what I'm going to do now is I'm going to substitute in 1 over root 5 where I have sine theta over 2. Now we just need to make sure that it's squared. So I need to square my value here. So if I can get rid of all this now, that's going to give me cos theta is equal to 1 minus 2 times sine theta over 2, which is 1 over root 5. But like I said, it's squared, so I need to put a square on that. Multiplying that out then on my calculator, or squaring it in my head, will just give me 1 minus 2 times 1 over positive 5. So cos theta is equal to 1 minus 2 times 1 over 5. And that's giving me cos theta is equal to 1 minus 2 over 5. And 1 subtract 2 over 5 is 3 over 5. So the question wanted us to find, use your formula to find the value of cos theta. Well, cos theta is equal to 3/5. Scrolling down now to part B to that question. So solve the equation. Tan B plus 150 degrees is equal to minus root 3, where B is between 0 and 360 degrees. So again, let's put down what we know. So we have tan B plus 150 degrees is equal to minus root 3. I'm going to use my log tables now, page 14. And on page 14, it tells me that tan A plus B, again, don't mix up this A and B. They're completely different. One's just from the formula and one's from the question. So don't get confused there. So tan A plus B is equal to tan A plus tan B, so this is just the formula basically, over 1 minus tan A times tan B. And I'm basically going to sub in I'm subbing in B for A, and I'm subbing in 150 degrees for B. So that's what I'm subbing in there. So that is that, and the B is 150. So that's giving me tan of B plus 150 degrees is equal to tan A, which now becomes tan B when I'm subbing in, plus tan 150 all over 1 minus tan A, which is now tan B, times tan of 150 degrees. Just make sure your calculator is in degrees when you're working out tan 50. So tan B plus 150 is equal to tan B plus minus 1 over root 3 divided by 1 minus tan B times minus 1 over root 3, which is giving me, so let's just multiply out that bottom part, minus 1 over root 3 by minus tan B. So that'll just turn that to a plus, but let's put each step in individually. So that's equal to tan B, taking this out of the bracket, will give me minus 1 over root 3, all over 1 plus 1 over root 3 times tan B. Okay, so I've just tidied up the signs there, basically. That's all I've done. Next thing I'm going to do is that I know that the value of tan B plus 150 is minus root 3. So I'm going to sub that in now. So I'm subbing in minus root 3 for tan B plus 180. So that's equal to tan B minus 1 over root 3. I'm just stuck for space here now, so just scroll down. Actually, I'm running out of the page here. So use of a little bit of Tipex there. Tan B minus 1 over root 3 all over 1 plus 1 over root 3 times tan B. And I'm going to put the minus root 3 over 1, and then I'm going to cross multiply here. So fraction equals to fraction. So common denominator basically. So it gets a little bit complicated there now. What's that going to give me? It's giving me minus root 3 times 1 plus 1 over root 3 tan B equals 1 times tan B minus 1 over root 3. And multiplying in my brackets, that's going to give me minus 1 root 3, or just minus root 3. Minus root 3 by 1 over root 3, well, that's just going to give me minus 1, isn't it? Times tan B is equal to, and then multiply in my second bracket, 1 times tan B is tan B, 1 times minus 1 over root 3 is just minus 1 over root 3. Actually multiplying in that 1, so let's just write it in, that just gives me minus tan B is equal to tan B minus 1 over root 3. Okay, moving tan B's to one side and numbers, constants to the other. So I'm going to add tan B to both sides and add minus 1 over root 3 to both sides. So what does that tidy up as? That's then going to give me minus root 3 plus 1 over root 3 is equal to tan b plus tan b. So minus root 3 plus 1 over root 3 is giving me, let's see, minus 2 root 3 over 3. And tan b plus tan b is 2 tan b. I'm then going to divide both sides by 2, which is giving me minus 2 root 3 over 3. I'll write it like this, divided by 2, instead of going a double fraction, is equal to tan b. And when I divide that by 2, I get, still stuck for space, let's come up here, I get minus root 3 over 3 is equal to tan b. I'm looking for the value of b, so I get tan inverse of minus root 3 over 3, which is giving me b is equal to minus 30 degrees. Now, if we scroll back up to the top of this question, it wants the values of b between 0 degrees and 360 degrees. So we need to focus in on that part now for a second. So what we're going to look at here is, let's just zoom out a little bit. So if we were to use our knowledge of cast here, so we're looking at our XY graph, and we have cos positive in quadrant 4, all positive in quadrant 1, S sine positive in quadrant 2, and T tan positive in quadrant 3. So minus 30 degrees is down around here. That's our negative 30 degrees. Now that means, don't forget, our solution here for tan is negative. So where are we looking for? We're basically looking for values for tan is negative. So tan is negative here in quadrant 4, and tan is negative in quadrant 2. So we're using our reference angle here of minus 30 degrees. So if I'm looking for this angle here, where tan is negative, so this angle here will also be 30 degrees. So I'm going back from 180 back 30 degrees, which brings me to a full angle here of 150. So my possible solutions for B are 180 minus 30, which is 50 degrees, so 150 degrees. And I also could have, well, I could also have the angle where I am, the negative 30. But if I just add on a full rotation, 360 degrees brings me to here. So if I go 360 plus negative 30, or just go 360 minus 30, which brings me to 330 degrees. So they're my two values for B, 150 degrees and 330 degrees. So starting off on part A, two identical right circular solid cones meet along their bases and fit exactly into a sphere as shown in the diagram. Prove that the volume of the remaining space inside the sphere is exactly half the total volume of the sphere. So basically what you're looking at here is your formula for a cylinder and your formula for a cone. And basically it's telling us that twice the volume of our cone, and our formula from our log tables is 1/3 pi r squared h. That's the volume of a cylinder, or sorry, of our cone. And if I let that equal to 2 multiplied by 1/3 is giving me 2/3 pi r squared h. Now if we look at our picture, the height of our cone is also the radius of our sphere, so I'm just going to change h for r. So when I sub that in, I get 2/3 pi r squared times r. So I'm just substituting in r for h, and that is going to give me 2/3 pi r cubed. Now the volume from our log tables of a sphere, so volume of sphere from our log tables is written as 4/3 pi r cubed. Now you can see here that the volume of my two cones is half the volume of my sphere, because if I take the volume of my sphere, 4/3 pi r cubed, and different ways you could finish out this question, I'm going to divide it by the volume of my two cones, so 2/3 pi r cubed, And when I divide the sphere by the 2 cones, I get 2. And that's telling me then that the 2 cones are half the volume of the sphere. So therefore, I'm just going to make my small little conclusion. Volume of sphere is double volume of 2 cones. And that's part 1. Part 2, it's telling us that the combined volume of the 2 cones is 686 over 3 pi centimeters cubed. Find the radius of one of the cones. So that is telling us that the volume of the 2 cones, so the volume of 2 cones is 2 multiplied by 1 over 3 pi r squared h, similar to part 1. I'm going to let that equal to my volume. So when I multiply in that 2, I get 2 over 3 pi r squared h is equal to volume, which is 686 over 3 pi. I'm now going to substitute in my r for h once again. So that's giving me 2 over 3 pi r cubed is equal to 686 pi divided by 3. In order to isolate the r cubed, I'm going to divide across by 2 over 3 pi. So that's giving me 686 over 3 pi, all divided by 2 over 3 pi. Again, a little bit of calculator work here. That's going to give me r cubed is equal to 343. And then to get r on its own, I need to find the cubed root of 343. And the cubed root of 343 is radius of 7 centimeters. And that's part 2. Scrolling down now to part B. So at 9 a.m. a delivery van leaves a factory. It travels towards its destination at an average speed of 60 kilometers per hour. An hour and 45 minutes later, a second van leaves the factory on the same route. It travels at an average speed of 95 kilometers per hour. Both vans arrive at their destination at the same time. Find what time they arrive at. Okay, so there's a bit of time, distance, and speed really is what we're looking at here. They both travel the same distance, basically, don't they? They're both going from a warehouse, the factory, to their destination. So they're both going the same distance. So I'm first of all just going to state that. Well, actually, let's see. I have van A. So I'm going to go my 9 a.m. van. And I'm also going to do out my 9 plus 1:45 van. So I just have 2 scenarios going on here. They're both traveling the same distance. And let's give that distance a value. I'm going to give it the value of x. So they're both traveling x kilometers. Okay, just listing out everything I know before I kind of get into the question. The speed of this van is 60 kilometers per hour. And the speed of my second van is 95 kilometers per hour. And I'm going to say that my first van arrives at its destination at, let's say, some time, and I'm going to call it t. So it takes a certain amount of hours to get from my factory to destination. Now, if I look at van 2 here, the van that leaves at 9 a.m. plus an hour and 45 minutes, it is going to travel an hour and 45 minutes less than the first van. So how do we write that time? That's going to be written as time, whatever amount of time the journey is, minus the 1 hour 45 minutes, or 1 3/4 hours. So what I'm doing there is that T stands for the time it takes to travel in the van. And for the second van, I'm taking away an hour and 3/4 because it travels less than the first van. So if I write that as a decimal, that is time minus 1.75. So it's 1 hour, 45 minutes, but it's 1.75 as a decimal. Okay, so I've written both of them now as arrival times. If I want to find the distance traveled by both vans, so let's look at our distance here now. From our junior cert days, distance, speed, and time. Distance is found by multiplying speed multiplied by time. Again, I'm doing it out for both of them here. Distance is equal to speed multiplied by time. Now on my first van, the speed of this van is 60 kilometers per hour, and the time, I'm writing it as just t. So the distance, my first van, is 60 t. Again, I don't know the value of t. Coming over to my second van, it's going to be a speed of 95 kilometers per hour multiplied by time. Well, it's now going to be t minus 1.75. Again, that 1 3/4 hours. And when I multiply in that 95, I get 95t minus 166.25. So that is the distance of the second van. Now again, remember that they're both traveling the same distance. So that means, therefore, that both of these are equal to each other because they are traveling the same. So that becomes 60t is equal to 95t minus 166.25. And a little bit of algebra now, putting t's on one side and constants on the other. So that's giving me, I'm going to subtract 60t from both sides. So 95t minus 60t, and I'm going to add 166.25 to both sides. Taking 60t away from 95t is giving me 35t, and to get t then on its own, I'm going to divide 166.25 by 35. So that is giving me, I'm just going to pull it up here now, that's giving me t, or time, as 4.75. Now this is time in hours, so 4.75 hours, which is 4 hours, and 3/4 of an hour is 45 minutes. Now, again, remember what's happening here. My first van left at 9 a.m. in the morning, and it travels 4 hours, 45 minutes. The question is asking us to find what time they both arrive. So I need to now add on 4 hours, 45 minutes. So the vans are going to arrive at their destination at 13:45 or 1:45 p.m. Question 6a is the Theorem 13 from our Leaving Cert course. So let's write down what we're given first of all. So the first thing I'm given is two triangles. The triangle A, B, and C are my corners, my vertices, and they will correspond to the similar triangle on the right, and I'm going to label the corners A dash, B dash, and C dash, because we know with similar triangles, the angles are the same size. So that's the first thing we're given. So let's follow that up by stating the angles that are equal. So I know that angle A is equal to angle A dash. I know that angle B is equal to angle B complement, and angle C is equal to angle C complement. So those angles are equal because it is a similar triangle. We know that the angles in a similar triangle must be equal. So that's basically what we're given in our diagram. We can also mark that those angles are equal if you want to maybe color them in on your diagram. So angle A is equal to A dash, angle B is equal to B dash, and angle C is equal to C complement. Okay, let's write down now what we want to prove. Basically what we want to prove is what's given up here at the top of the page in the theorem in our Leaving Cert. So we're basically just going to write that down. That's what we want to prove. So that's what we would need to prove now. Just take a minute yourself maybe to look back on our diagrams to make sure and satisfy yourself that that's the case. Basically you're showing that the sides are proportional, so the side AB is proportional to A dash B dash. You're showing then that the side BC on the larger triangle corresponds to B dash C dash. I'm just missing my dash there in my B. And on my third side, AC is proportional to A dash C dash. So that's basically what we're trying to prove, that they are equal, or in other words, proportionate to each other. So now we're going to go down and mark in our constructions. And as you know, our constructions are basically what we mark on our diagram. So to make, again, life a bit easier here when you're viewing the video, I'm just going to copy down my diagram from up above just so we can follow it. So the first construction I'm going to make is I'm going to mark a point on the larger triangle on the left. And the point I'm going to mark, I'm going to call it B dash dash. So it's going to basically be the mirror image of our angle B, our vertex B and B dash. And it's going to be marked on the triangle AB. Now, where I'm going to place it is basically going to be on the line AB. So I'm going to put it here. And what's going to happen here is that where it's located is the same distance from A. So the length of that line must be the same length as A dash B dash. Okay, so to imagine a line coming across here from B dash over to my new B dash. I'm basically putting my smaller triangle into the bigger triangle. So hopefully you can visualize that. So that's my B dash. And I'm just going to write that down. So what I've drawn. Okay, so I've marked the point B dash on the line AB, and now I also want to state that its length is AB dash dash is equal to A dash B dash. So it'll make sense now when it's written down. Okay, so that's what I know is true. Again, look at the diagram. Basically what that means is that the distance from A to B dash is the same as the distance from A dash to B dash. That's basically what that means. Okay, so next thing we want to mark is the image of C dash over on our larger triangle. And once again, it's going to be located somewhere around here, and it has to be the same distance as C dash is from A. So it's going to be located here. So I'm going to label that point. Now I'm going to label it C double dash. So it'll have two dashes there, because again, all of these C's are the mirror image of each other, because I'm trying to keep that similar triangle approach each time. So I'm going to write that down. So basically what I'm doing here is I'm marking the point C dash dash on AC. And I've also stated that the distance from A to C dash dash here is the same distance as it is from A dash to C dash. Okay, so that's basically everything that I want to construct. I have one more construction that I'm going to make, and it's just basically going to be a straight line. And it's the straight line which is going to connect B dash to my C dash. So I'm just going to mark it in here. So I'm joining a line from B dash across to C dash. So in other words, basically what I've done here is I basically picked up my smaller triangle and I've placed it into the larger triangle. So it fits in up here. That's basically what I've just constructed. Again, we just need to write that down. So what I'm going to write down is that I've joined B double dash to C double dash. Okay, so that's all our constructions. Next thing we're going to do now is we are going to move on to our proof. So we are now doing our proof. And once again, as I said at the start of the video, we are going to need a lot of our Theorem 12 knowledge here. So make sure you viewed Theorem 12 before moving on here. So the first thing we know is that we have two congruent triangles. We have the triangle A dash, B dash, C dash is congruent now to A, B double dash, C double dash. Those two triangles are congruent because we fit the smaller triangle into the larger triangle through our constructions up above. So that's the first thing I'm going to note here as part of our proof, so that those two triangles are congruent. Okay, so that's the first thing that I'm stating, and I'm basically just going to use a little bit of a process that we did with our congruent triangles. I'm basically just going to be making statements here, and I need to give a reason. So I'm through my proof. These are the how I'm going to do it. So I'm going to make a statement, and I'm going to also state why that is the case. And why are those two triangles congruent? Well, I could look at the likes of I could do side angle side perhaps. That's one way we could have looked at it. Again, remember we can't use the three angles, but I could use the side A B dash dash is corresponding to A dash B dash. So have a look at that and I'm sure you can figure out why they are congruent. But that's one way we could do it, side angle side. Okay, what I want you to see now is we're going to look at some angles. So we know that this angle in here, angle A B double dash C double dash, is equal in size to this angle here, ABC. So those two angles are going to be equal in size. And the reason why they're equal in size is because they are corresponding angles. We could say now that the two sides, B to C, is parallel to the line B dash dash C dash dash. Those two lines are parallel to each other because we fit that small triangle into the larger triangle. So we know that they are parallel to each other. So basically that's all I'm going to state. I'm going to state that those two green angles are equal in size. And my reasoning for that, the reason for that is that they are corresponding angles. As you know, because the two lines are parallel to each other. Okay, and from that now, because those two angles are equal in size, we can now conclude that the length B double dash C double dash is equal to BC. That they are parallel to each other. So that's what, sorry, not equal in length, they're parallel to each other. So that's what we can conclude from that statement. So we have our two angles are equal. Remember that the congruent triangle fits into that larger triangle. So that's why we are saying that they are, again, I meant to rub out my equals, they're not equal, they are parallel to each other. So we know that the length BC is now parallel to B double dash C double dash. Okay, now what we can state is that we know from our knowledge of Theorem 12, because the two triangles are fitting into each other, Theorem 12 now states that those sides are proportional. So from that, we can now state that, I'm just going to zoom in here for 1 second so I can make a bit of room. So we can now state that the side AB over A double dash B, so that side there, is proportionate to AC over AC double dash. So just take a second to look at that. So the side AB over A double dash B is equal or proportional to AC over AC double dash. Again, that's because of Theorem 12, and we don't need to prove that again. We've done that proof in Theorem 12. And from there then, we can extend that even further. We can now say that the side AB over A dash B dash is equal to AC over A dash C dash. We're just basically extending that knowledge of just up above. So again, I'm just going to zoom out a little bit so we can get our picture. If you look up at our picture, what I mean by that is that the side AB is corresponding to AC. So you can see here that they're the two longer sides on the triangles. And on the bottom of my fracture, or the denominators, is going to be A dash B dash and A dash C dash. Okay, because we know that that's the same as the length from A to C double dash, just from up here. We know that they are the same thing. And finally, we're going to make our final statement, which from there, we can now say that B dash over C, or sorry, BC over B dash C dash is equal to AB over A dash B dash. Okay, so that's basically what we can conclude. And you can see here now that we're basically finished because we have our AB over A dash B dash is equal on top and bottom. So that must mean then that the AC over AC dash must equal the BC over B dash C dash. So hopefully you can see there that you can see that both of these are on the top and the bottom. So logic follows that the other two sides must be proportional as well. So basically what you're stating there, our final answer is basically what we wanted to prove, and that was AB over A dash B dash is equal to, because that's this part here basically, is equal to BC over B dash C dash, which is this part here, and that is also equal to AC over A dash C dash, which is this one here. Part B is asking us to prove the following and to give a reason for each geometrical statement that you use. So let's just mark off these line lengths first. So AH, we have the line segment QB, we have the line AP, and we have the line HB. So you can see here that as I mark them off, we're forming two triangles. So I'm just going to join this line segment PHQ. So you can see here that we've made basically two triangles out of it. And what we're going to basically show is that those two triangles are similar to each other, and we'll be able to then make the link to part A of this question as well. So let's write some pieces of information that we know. So let's look at the angle QBH. QBH is this angle here. And I'm going to say that that angle is equal to the angle HAP, which is this angle here. And the reason why those two angles are equal is because they are alternating. They are alternating angles. And the next statement I'm going to make is the angle BQH is equal to the angle HPA. And that angle is BQH. I'll just put a little X on that angle. And HPA is this angle here. So don't mind that line segment there, P to K, just imagine that it's not there. And the reason why those angles are equal again is because they are alternating. Now to prove similar triangles, you only need to show two angles are equal, but let's prove the third one. So you could have also used the angle BHQ, which is this angle in here. Let's just put a little square in there, and that's equal to the angle PHA, which is this angle here again in a square. And the reason why they are equal is because they're vertically opposite each other. So now that we've proved that all three angles are equal in both of the two triangles, I can now conclude that triangle HBQ and HPA are similar to each other. And because these two triangles are similar, it means that the lengths of their sides are now going to be proportional. So similar to the proof in part A, we can now say that the side AH is proportional to the side BH. And if you look at the image, that's because I'm going from the dot to the square. So I'm just going to write my little bit of rough work there. That's the line segment between a dot and a square. That's equal to, I can say the side PA over side QB. That's going from an X to a dot from my picture. And that's equal to PH over QH, which again is going from the X to the square symbol. Now at this stage, I'm trying to see which two fractions I'm going to use. We're going to just kind of come to the question and see. So it's using AH, so I need to match up an AH, which is here, QB, which is QB, matching up with an AP, and I'm using HB, which is HB here. So I'm ignoring this third fraction basically. So I'm kind of using the question to help me match up my fractions. And by using a little bit of simple algebra here, I'm basically just going to simply cross multiply, or basically getting common denominators. And when I cross multiply, I multiply AH by QB, and I get, I'm just going to come over here instead of scrolling down, I get AH times QB, and that is equal to AP multiplied by BH, or that can be also HB. And that's what they wanted to ask me at the top of the question. Prove that AH multiplied by QB is equal to AP multiplied by HB. And we are done. So similar triangles is the answer there to part B. 2021 paper 2 question 7. Let's fill in some information onto the diagram. First, what we know is that the swim is 4 kilometers from C to B. And we know that the run is from A to C, which is 28 kilometers. In part A of the question, it's asking us to show that the total length of the course is 62 kilometers. So that basically means we need to find how long or what the distance of the cycle was. Just putting down some information about the cycle, we know that the speed is given in the question at 25 kilometers per hour. So that's the speed of the cycle. The time of the cycle, we also know, and it took 1 hour and 12 minutes. I'm just going to convert that into a decimal, which is 1.12 out of 60, so 12 over 60 minutes, which is 1.2 hours. And the question then is asking us to get the distance of that cycle, and I'm going to look at my distance, speed and time triangle. And the question is asking me to get the total length, which is the same as distance, which basically is asking me to multiply speed by time. So distance is given by speed multiplied by time. And in this particular question, my speed is 25 kilometers per hour, multiplying it by 1.2 hours, which is giving me a total for the cycle of 30 kilometers. And the question then wants us to prove or show that the total length of the course is 62 kilometers. Well, let's just double check that. So total will be my 30 from my cycle. I have my 28 from my run. And I'm going to add on my 4 from my swim. And when I add those three figures together, I get 62 kilometers. And that's what they wanted me to prove. Scrolling down now to part B. On average, Mary can run 5.6 times as fast as she can swim. It takes her 4.8 hours to complete the course. Find her average swimming speed in kilometers per hour. Okay, so what do we know here? So we know that the full course is 4.8 hours. They've given us that. We know that the time for the cycle from up above in the question is 1.2 hours. We converted that in part A. So if I take them away from each other, I get 3.6 hours, and that would give me the total time to complete the swim and the run. So the swim and the run together took 3.6 hours. So that's something we know. So I'm just going to write that down. Swim plus run is equal to 3.6 hours. Now in the question it says that Mary runs 5.6 times faster than she can swim. So if we kind of look at our formula for time, so again I'm looking here at my distance, speed and time triangle. If I want to find time, I'm looking at distance over speed. So if I look first of all at maybe the swim, what would that look like with my swim? So the distance of the swim is 4 kilometers. And the speed of the swim is unknown to me. I don't actually know what that is. So I'm just going to put in maybe an X to represent the speed of the swim. I don't know what it is. Let's look now at putting back in my plus sign. And then I'm going to examine the run part. So I'm putting in my swim plus my run. That must equal to 3.6 hours. What about the run? Again, I'm focusing here on this time. And the distance is 28 kilometers. We have that again from the top of the question. And I'm not going to now put it over speed. Again, I don't know what the speed is, so I've called that X. But look at the question. It tells us that her speed is 5.6 times faster than the swim speed. And I've apportioned X as the speed of the swim. So that means basically then that the speed of the run is 5.6 times faster than it. So basically I'm multiplying it by 5.6. So I'm going to change this to 28 over 5.6x, 5.6 times faster than the swim. And that is going to equal to my total time for the swim and the run, which is 3.6 hours. And now you can basically see that I have an equation with two fractions in it. And I'm going to basically put that 3.6 over 1 to make three fractions. And how do we solve algebraic fractions? Basically, I need to find my common denominator. And my common denominator here is going to be 5.6x. That's my common denominator. And I'm basically just going to rewrite my three fractions. So my first one plus my second one equals my third one. Now the middle one is already over 5.6x, so I'm not doing anything to that one, so it just stays as 28 over 5.6x. The first one though is going to change. It's 4 over x, so I need to multiply top and bottom by 5.6. So 5.6x, and in the top I had a 4, and I'm now going to multiply that by 5.6. So if I multiply the bottom by 5.6, I need to multiply the top by 5.6. And coming over to the 3.6 hours, it was over 1, so I need to put that over my common denominator, 5.6x. So that means I need to multiply the top by 5.6x. And working that out, 5.6 multiplied by 4 is getting me 22.4 over 5.6x. Plus 28 over 5.6x equals 20.16 x over 5.6x. Now I'm going to drop my denominator because they're all equal to each other. So therefore I basically just need to solve the linear equation. 22.4 plus 28 equals 20.16x. Adding the left-hand side gets me to 50.4 equals to 20.16x. And to solve for x on its own, I divide both sides by 20.16, which basically gives me a value of x as 2.5. And if you come over to the left-hand side here, I assigned x as the speed for the swim. So basically, my final answer is basically the speed of swim is 2.5 kilometers per hour. And that's basically what the question wanted. If we go back up, it says find our average speed of the swim. So 2.5 kilometers per hour. Looking now at part C. So show that the angle ACB is equal to 116.5 degrees. Give your answer to one decimal point. So first thing I'm going to do here is I'm just going to sketch out my triangle rather than moving back and forth to the top of the page. So we have C, A, and B. Filling in what I know, that was 4 kilometers. We had 28 kilometers, and we solved that to be 30 kilometers. They basically now want me to find the size of the angle C, or show that the angle C is 116.5 degrees. I'm going to use my cosine rule for this. My cosine rule from my log tables is written as a squared equals b squared plus c squared minus 2bc times cos of a. And my A is the side opposite the angle, so 30 is going to represent my A. Angle A I'm going to change to my angle C, and the 28 and the 4 are my side B and side C. So filling that in, I have 30 squared equals 28 squared plus 4 squared minus 2 28s times 4 times cos of C. 30 squared is 900, 28 squared 784, 4 squared 16, 2 28s times 4 is 224 cos C. I'm now going to add 784 plus 16, which gets me 800, so I have 900 equals 800. Don't take away that 224 from the 800 because it's stuck to the cos C. So I need to follow my rules of BIMDAS here. Multiplication comes before subtraction, so that's why I'm not subtracting it there. Next thing I'm going to do is I'm going to take 800 away from both sides, or move that 800 over. So that gives me 900 minus 800 is equal to minus 224 cos of C. So that's 100 is equal to minus 224 cos of C. Next thing I'm going to do is I'm going to divide both sides by minus 224. So 100 divided by minus 224 is equal to cos of C. And to get C in its own, we're going to use tan inverse. So tan inverse, you can turn that into a decimal. I'm going to leave it as the fraction though. 100 over minus 224. And the inverse of that is giving me a size of an angle of 116.51. And the question wants it to one decimal place, so 116.5 degrees. Looking at D, to comply with safety regulations, the region inside the triangle must be kept clear of people. Find the area of this region. So we're looking basically for the area of a triangle. We don't know the perpendicular height of this triangle, so I can't use half the base by the perpendicular height. So the formula that I'm going to use here now is area of triangle as half AB sine C. Again, from our log tables, the area of a triangle when we know one of the angles. And filling that in from my picture up above, the area of this triangle is going to be half times A, which is 4, times my 28, and times the angle between them, which is sine of 116.5 degrees. And when I work that out in my calculator, I get an area of 50.1 kilometers squared. Again, question wants it to one decimal place, so just make sure it's 50.1. Scrolling down now to part E. Part E is telling us to find the shortest distance from the point C to the side AB in my triangle. So again, let's just very quickly sketch out that triangle so we can visualize it. And we have 28AC, 4B, and 30. The shortest distance from the point C to the line AB is this line here. And the shortest distance will always create a 90 degree. So basically that red line is perpendicular to the side AB. And for this one, I'm going to come back now. I know that the area of my triangle is equal to 50.1. I have that from part D up above. So I'm going to use that. But I'm actually going to come to my other formula for area. Area is equal to half the base by the perpendicular height. And that perpendicular height is that red line basically. So I'm going to fill that in. Area 50.1 equals half the base. The base of this triangle will be my AB, which is 30, times the perpendicular height, which would be this new red line that I've drawn in. And I'm just going to call that P for perpendicular. So that gives me 50.1 is equal to half of 30, which is 15, times P, which is 15P. And P then is equal to dividing both sides by 15, which gives me a perpendicular height, or shortest distance basically, is what we've found, as 50.1 divided by 15, which is 3.34, but it wants it to one decimal point, so 3.3 kilometers. So the distance from C to the line AB at its shortest distance is 3.3 kilometers. And there's one last part to it, part F. The course is viewed from a camera tower which rises vertically from the point A. So this is our tower here. The top of the tower is point T. The angle of elevation of T from B is 0.05. Find the height, the distance basically, of AT, the vertical height. So there's key words there. Vertical meaning it's going to create that 90 degree angle. So it's going basically, if you think about it, from the top of the tower, and the angle is going to B. So I'm basically looking at this triangle here. The triangle I'm looking at is going from T down to A. That's the height of my tower. Then it goes, it's vertical, so it creates that 90 degree. And I'm going all the way over now to my angle, or my corner B. So that's basically the triangle I'm looking at, ATB. We know some information about it. So from the previous parts of this question, we know the distance from A to B is 30 kilometers. We don't know the height of the tower. That's what they're asking us to find. So I'm going to call it X. We don't know anything about T to B, but we know that the angle from B to T is 0.05 degrees. So we have those three pieces of information, and it's a 90 degree triangle. So I'm looking at my trigonometric ratios here, basically sine, cos, and tan. So we know that sine is O over H, cos is A over H, and tan is O over A. And if you look at your triangle, filling in the pieces of information, opposite is going to be AT, that's opposite the angle. Hypotenuse, opposite the 90, and adjacent is my 30 degrees. So I'm basically using the 30, which is my adjacent. So that has cos and tan. And I'm also using my opposite, which is O in tan and sine. So basically you can see there I'm using tan. So I'm going to look at tan of the angle is equal to opposite over adjacent, which gives me tan of 0.05 degrees is equal to opposite, which is my AT, or X, I'll just call it AT, and adjacent of 30. I'm going to put my tan 0.05 over 1, simply cross multiply to solve these fractions. So I'm getting 30 times tan of 0.05 is equal to the distance AT. And when I solve that, I'll just keep going this way, make it a little bit easier. Hopefully you can understand all that. 30 multiplied by tan of 0.05 is giving me 0.02618 kilometers AT, because don't forget that this course is measured in kilometers. But the question though doesn't want it in kilometers, it wants it to the nearest meter. So I need to convert that 0.02618 kilometers into meters. And we know that there's 1,000 meters in a kilometer. So I'm going to multiply that by 1,000, which gives me 26.178 meters. And the question wants it to the nearest meter, which is 26 meters. So the height of that tower is 26 meters. And that's us finished. So question 8a, part 1, find the minimum mark needed on the exam to progress to the county stage. So the important bit here is the normal distributed. So that's drawing our attention to the bell curve, and we're just going to sketch that out here just so we can visualize what's happening in this question. And it's telling us then that we have a mean mark of 176, and it then tells us that the top 10% progress to the county stage. So we're basically looking for this percentage here that allows these 10% of students to progress to the county stage. From page 36 in our log tables, we read our percentages from right to left. So it's going this way basically. So what we're basically looking at here is 90%. So we're going to 100%, take away the 10% that go through, which is marked in green there. But again, like I said, we read our normal distribution from right to left. So all we can examine here is 90%. The 90% which is in white on our bell curve. And if we go and transfer that 90% to a z-score, 90% gives us a z-score of 1.28%. So the nearest one to 90%, the nearest percent in our page 36 of our log tables. So I'm looking for 0.90. The closest I can see is 0.8897, which is giving me a z-score of 1.28. And I'm then coming up and I'm going to solve that now to find out the percentage of the marks. So I'm filling in my z-score here and I'm putting in the x is what I need to find. My mu is the mean, which is 176, and sigma is my standard deviation, which is 36. Z is my z-score, which is 1.28. And then it's just a little bit of simple algebra here. Cross multiply is going to give me x minus 176 equals 36 times 1.28 is giving me 46.08. Adding 176 to both sides, 46.08 plus 176 is giving me a mark of 222.08. Now the minimum mark though is going to be rounded up. So the minimum mark that you need to receive is 223 marks. Because think about this, if I got 222 marks, I'm still going to be below that 10% that I need. So 223 is the minimum mark needed to progress. Looking now at part 2. The school awarded a certificate of merit to any student who received between 165 and 210. Find the percentage of first year students who received a certificate of merit. Again, let's just look at our bell curve. What would this look like? So once again, there's a sketch. We have our mean of 176. We have 165, which is below it. So that'll give us a negative when we use your z-scores, and we have 210. And we're basically looking for this region between the two percentages. So I'm looking for what's the value of that in percentage. I'm using my log tables again, my standardizing formula, page 34, which is x minus my mu over standard deviation equals my z. So I'm drawn to page 34 for that. And let's have a look at it. So we need to do it out twice, basically. So we need to do it out for the 165 marker, and we have to do it out then for the 210 marks. So let's do it out twice. So my first one here, 165 marks, and then I'm going to do it out again for 210 marks. So I'm doing out my formula twice. So filling it in, I have my x, which is 165 marks, minus my mean, which is 176, over my standard deviation of 36, and that gives me my z-score. And for my 210 marks, it's the exact same, 210 minus 176 divided by my standard deviation, which is equal to z. And working that out, I get minus 0.306 is equal to z, and I get 0.94 is equal to z. I'm just going to write that to one decimal point, so minus 0.31 is equal to z, so that's my z-score. I'm going to go to my log tables and look up positive 0.31 in my log tables because I don't have negatives, it's symmetrical. And when I look up positive 0.31, I'm getting a z-score probability of 0.6217. Now I need to subtract this from 1, which is giving me 0.3783. I'm subtracting that from 1 because I had a negative z-score. I'm coming over now and I'm going to look at the 210 marks, and I got my z-score to be 0.94. Not a lot more to do with that, so the probability of z being less than 0.94 is, from my log table, 0.8264. And I'm practically done. All I have to do now is, in order to get that yellow portion, I need to subtract my two answers from each other. So 0.8264 subtract 0.3783 is getting me 0.4481. The question said find a percentage, so I'm timesing that by 100 to give me 44.81%. And that is part 2. Scrolling down now to part B. B part 1, find the test statistics, i.e. the z-score of this sample mean. So the test statistic is coming from page 35 in our log tables, and it's written as z for our z-score is equal to x minus my mu over standard deviation divided by the square root of n. Let's find out a little bit of information here. So what do we have? We have the 21 hours here, which is my population, so that's my mu, and I have the average study time from the sample was 19.8, so that's my sample, so that's my x. I have my 60 is the number of students, so that represents my n, and my standard deviation is given here at the end, which is my 5.2. So I have all the information there. Now I just basically have to fill it into my formula. So z is equal to x, which is 19.8, subtract 21, divided by 5.2 over the square root of 60, and that is giving me a test statistic of minus 1.788. And that's B part 1, not too difficult there hopefully. And B part 2 now. So it's asking us to find the p-value, and first thing I'm going to do here is draw out our bell curve just so we can get a little bit of context what the p-value is asking us to do. And the p-value is measured at a 5% level of significance, so our 5% here would be 0.05 as a decimal, which would basically be 0.025. That would be 2.5% at the top end, and it's same at the bottom, 2.5%. So that's where the 5% is coming from, and 0.025. Working out my p-value now, from the first part of the question, we got a z-score of negative 1.788. And I'm going to just go to 2 decimals. That will give me negative 1.79. And if I look that up in my log tables, again, I'm looking for, again, it only does positive. So I'm going to find the probability of 1.79. So I'm looking up a z-score of positive 1.79, which gives me the probability of 0.9633%. And again, let's go and take that away from 1, because we are not looking for positive 1.79, we're looking for negative 1.79. So again, if we just looked at that on a bell curve, again, it's only a rough sketch, that there would be 96%, 0.9633, and which is 1.79 as a z-score, but we're looking for negative 1.79, which is down here. So I'm not basically looking for all of this, I'm only looking for the parts down here. So that's why we have to subtract it from 1, because it's symmetrical. In other words, we're basically trying to find this here. So therefore, the probability of my z, my being less than 1.79, is equal to 1 subtract 0.9633, which is 0.0367. Let's just rub this out, because that was just our rough sketch. So what does that mean? Now I just need to multiply that by 2, because it occurs at both ends of my bell curve. So my p-value is equal to 2 times 0.0367, which is working out at 0.0734. And I'm going to times that by 100 because it's asking for a 5% level of significance. So let's turn it into percent, 7.34%. That's my p-value. What's my conclusion? So my conclusion is that since my p-value of 7.34% is above 5%, we then do not reject the claim made by this news reporter. So let's just put that into a little bit of text. Okay, so since the p-value of 7.34% is greater than 5%, we do not reject the claim made by the news report. If your p-value is less than 5%, then you do reject. So you're looking for that 5% level of significance. Moving on. Part C1. The school caretaker has a box with 23 room keys in it. 12 of the keys are for general classrooms, 6 for science labs and 5 for offices. 4 keys are drawn at random. What's the probability that the 4th key drawn is the first office key? Okay, so we have 4 keys being drawn out of this box. So let's just go with K1 for key 1. We have key 2. We have key 3. And we have key 4. Now the first key that's drawn out of the box cannot be an office. So I'm just going to go not office. Okay, so we don't want an office. And my second key is also not going to be an office, because I want the office key on the 4th attempt. And my third one is not office. But this is where it changes. My 4th key is now going to be the office. This is when I want the office key. I want it on the 4th attempt. And looking at these now as percentages or fractions, what's the probability for key 1 not being an office key? Well, that would be the 6 from the science and the 12 from the general classroom. So that's 18 keys. So the first key is 18 out of 23. So 18 coming from the 6 and the 12 from the general and the science, giving me 18 and a total of 23 keys. Now I'm going to assume here, it doesn't say it in the question, but I'm going to assume that the keys are not being replaced. So when I get to my second key, not being an office, that 18 is going to reduce down to 17 because I've assumed that one of those 18 keys is my science or my general. I've taken that out, I've put it aside. I only have 17 of them left. But I now only have 22 keys left in the box. So that's key number 2. And in probability means to multiply, so I'm going to put in my multiply signs here. The third key is going to reduce now to 16 out of 21. And then finally, when I get to the office key, well, the office key has 5 of them. And that's out of how many keys remaining? I'm down to my 20th key. So I just go to my calculator now and I'm going to work out 18 over 23 multiplied by 17 over 22 multiplied by 16 over 21 multiplied by 5 over 20, which is 204 out of 1,771. As a decimal, 0.1152. The question said to give it to 4 decimal points. Okay, looking now at C part 2. All the keys return to the box. Then 3 keys are drawn at random from the box, one after the other, without replacement. What is the probability that one of them is for a general classroom, one is for the science lab, and one for the office? Okay, so we're picking out 3 keys here, aren't we? Key 1, I'm going to say, key 2, and I'm also taking out key number 3. So I'm taking 3 keys. Now, what sort of orders could these keys come out in? Like the first key I take out could be for the general classroom. The second key then could be for the science. And the third key could be for, what's my third one? An office. So that's one possible order. Now, what's the probability of that actually happening? We could have, well, what's the general? There's 12 of them. So it could be general classroom out of 23. And I have 6 for science out of 22. Again, it's not being replaced. And again, meaning to multiply, 5 for the office out of 21. And that's my total there. What's that? 60 out of 1,771. So that's one possible order. But that's not the only one. What else can we have? We could have the general classroom. We could have an office, then followed by the science room. So we have to look at that situation. And I'm looking at general, science, office, or general, office, science. So or is important here. We need to include that word or. And in maths, in probability, or means to add. So we need to add on these fractions. Now, what's the probability of getting a general, an office, and a science? Well, they're basically the exact same. The order is just changing. So I've general being 12 out of 23. I have an office being 5 out of 22. And I have a science being 6 out of 21, which is still giving me the same answer. I'm still multiplying the same numbers to get me 60 out of 1,771. So all I'm going to do now is I'm going to fly through all the different combinations. So what else could we have? We could have had a science, general, office. We could have had science, office, general. We could have had office, science, general, office, general, science. That's it. We have 6 of them. Now, again, you can list them out if you want, but all 6 are going to give me the same answer. They'll be in different orders, but they will give me the same 60 over 1,771. 60 over 1,771, 60 over 171, and so on and so on. Basically, I have it, 6 times? So I'm going to cut a little corner here, just go 60 over 1,771 times by 6, which is giving me 360 over 1,771. And the question said the 4 decimal points, so I'm going to hit my SD button on my calculator, which gives me 0.2033 as a decimal. And that's C part 2. That's the end of question 8. Question 9a part 1 is asking us to find how long it took to fly from B to C. Give your answer correct to the nearest minute. So it's talking about time here. So this question is going to need our knowledge of our distance, speed, and time triangle. And let's fill in a bit of information onto the diagram. So it tells us, first of all, that it travels from A for 2 hours at a constant speed of 420 kilometers until it hits B. So that means that the total distance, so from A to B, is going to be 420 kilometers multiplied by 2 is giving me 840 kilometers. So I'm just going to mark that onto my diagram. It's 840 kilometers from A to B. The next piece of information I also know is that this angle here at B must add up to 180 degrees because it's a straight line angle. So I'm just going to mark in the angle internally here, which is going to be 160 degrees, because 180 take away my 20 is leaving me with 160 degrees. And that means I can fill in the third remaining angle in this triangle, which is going to be 180 degrees minus the 8.57 plus the 160 degrees, which is giving me an angle of 11.43 degrees. So that's as much information as I know. Coming down now, let's do a little bit of work here. I'm going to find, well, what's it asking us to do? Find how long it took to fly from B to C. So basically, I'm getting that length there. So I'm going to use either my sine rule or cosine rule. I'm going to use my sine rule, which is from my log tables. A over sine A equals B over sine B. Now we can go other ways with this question. Sine rule would be, or cosine rule would be fine. Let's just use the sine rule to keep it simple. The side I need is BC, which is along here. So I'm going to call that my A. So my BC is my length I'm trying to find. And that is over the sine of 8.57. So think about this. The angle is opposite the side. And the side or the angle opposite BC is the angle A, which is 8.57. So sine 8.57. And I'm going to match that up with one other side. Well, I know the length of A to B, which is 840 kilometers. And I'm going to put that over the angle of sine of 11.43 degrees. Now, I could have went with the 1450 over the angle of sine 160, but it's the same thing. Solving this now, I'm going to cross multiply my two fractions. And that is giving me sine 11.43 multiplied by BC. So I'm just going to keep that as is. You can turn them into decimals if you want. I'm going to leave them in their original form here just to make life a bit easier. Is equal to 840 times sine of 8.57. Again, you can multiply them out. I'm going to divide both sides then by sine 11.43 to get the length from B to C. So that's 840 times my sine of 8.57 all over sine of 11.43 degrees. And I'm just going to go to my calculator and work that out. And that is giving me BC equals to 631.65, which is 632, we'll round it to the nearest, and that is kilometers, so 632 kilometers. Now the question though isn't asking for the distance from B to C, it's actually asking us to find the time taken to get to B to C. Now we know though from our distance, speed and time triangle, in order to get time is found by dividing the distance by the speed. So in order to calculate the time here, I'm going to take my distance, which is 632 kilometers, divided by the speed. Now the speed is constant at 420 kilometers. That's given in the top here in the question. So when I divide that out, I get time equals to 1.5, which is 1.5 hours. And the question said give it to the nearest minute, so I'm going to write it as 90 minutes. 0.5 is standing for 30 minutes, so 60 plus 30 is 90 minutes. Part B is asking us the average fuel consumption of the plane is 3.8 litres per second and the fuel capacity of the plane is 100,000 litres. Show that the plane will be able to complete the journey from A to B to C and directly back to A at the speed of 420 kilometers per hour. So it's assuming that it's a constant speed of 420 kilometers. So we don't need to worry too much about that. Let's just write down what we know. So let's focus in on the actual total length of the journey first of all. So I'm going to write down the total length of journey, or the total distance in other words. So to go from A to B, it was 2 hours. Again, that's given at the top of the question. We figured that out by multiplying Or sorry, no, they did give it 2 hours, so we know that. What's that? That's 120 minutes if we're working in minutes. The time from B to C is from part 1 up above, which is 1.5 hours, which we found out to be 90 minutes. That was my answer to part 1 up above. And now from A to C. What's happening from A to C? Well, the distance from A to C is 1,450 kilometers. And if I divide that by the speed, 420, again, I'm focusing in here on my distance, speed, and time triangle, and I'm trying to find time, which is found by dividing distance by speed. So if I divide 1,450 by 420, I get roughly 3.45 hours, which is the same as about 207 minutes, give or take. So if I calculate the total length of the journey in minutes, I'm getting 417 minutes. So that's the total length of the flight. The question says, though, that the plane travels 3.8 litres per second. So I need to turn that 417 minutes into seconds. So I'm multiplying by 60 because we know there's 60 seconds in a minute, which is 25020, 25,020 seconds. Now your answer might be slightly different, given that I round the distance or the time taken from A to C to be 3.54. So let's look at the consumption now of the airplane. So the total consumption is the 25,020 seconds. I'm going to multiply that by 3.8 litres because it uses 3.8 litres per second. So therefore, my flight is taking 95,076 litres of fuel to complete the flight. And the question is asking us, show that the plane will be able to complete the flight. Well, it is because since 95,076 litres is less than the 100,000 litres that the airplane can hold, therefore it is able to complete the journey. Just make sure we state our conclusion in this question. So they want you to show it, but you must state your logic there. So because the 95,000 litres is less than 100,000 litres that's on the airplane can complete the journey. Okay, scrolling on down. Part B, the voltage of a certain alternating current is given by this function. Find the period and the range. Okay, so my function here, if we just write it out in terms of A and B, so my A is my 110 root 2 sine B times t. My B is standing for the number in front of the variable, the t. So in order to get my period, I divide a full rotation, so 2 pi, and I divide that by my B, and in this case, my B is 120 pi, so 2 pi divided by 120 pi is giving me 1 over 60. So that's my period for this question. So 1 over 60. The range then is found from taking the modulus of the A, so negative and positive A. So my range is going from minus 110 root 2. So the 110 root 2 is basically my amplitude. So minus 110 root 2 up to positive 110 root 2. That's it. That's my period and my range found for part 1. So my range is always found from minus A to positive A. Looking then at part 2, sketch the function. So this is just asking us, I'd say, just keep it very, very sketchy. Let's just draw out my coordinate graph. Something like this, and the highest value there I'm going is 110 root 2. Again, that's my amplitude, and if I'm including my range, it would bring me down to negative 110 root 2. A sine function will always go through the origin, and my period is 1 over 60. So basically, let's just sketch a sine function going through the origin, up and down, something like that. And we know, let's just mark a bit of information on it, that from here to here, that's my range, which we know. And my period then is going, let's just say from here to here, which is 1 over 60. So where it crosses the axis again here, that coordinate there would be 1 over 60 if I'm starting at the origin of 0. I think that's enough. That's all we need. I've marked in my range and I've marked in my period. Looking at part 3. Use the formula, the function for volt, to find the voltage when t is equal to 6.17. So that's fairly straightforward. So my function is Vt is equal to 110 root 2 sine of 120 pi times t. All I'm doing here is I'm subbing in 6.67 for t. So the voltage at time 6.67 is equal to 110 root 2 times sine of 120. Just be careful here, it's calculator work, just maybe put them in brackets just to make life a bit easier for yourself. 6.67. So again, just be careful with your brackets on your calculator perhaps. So voltage at time 6.67 is equal to 147.94967 on my calculator anyway. Give your answer to 2 decimal points, so that's 147.95 volts. Okay, that's part B done. Looking now at B part IV. Find one value for t when the voltage is 110 volts. Give your answer in the form of a fraction. So let's just put down our formula again here for voltage. It's written as 110 root 2 sine 120 pi t. Now they want us to solve for t when the voltage is 110, so I'm going to let this equal to 110. I can divide both sides by 110. That's the first thing I'm going to do, divide by 110 on both sides. So that's giving me root 2 sine 120 pi times t is equal to 1. So 110 divided by 110 is 1. Dividing both sides by root 2 is giving me sine 120 pi t is equal to 1 over root 2. To get 120 pi t on its own, I'm going to find the sine inverse. So therefore, 120 pi times t is equal to sine inverse of 1 over root 2. So in order to get rid of the sine, I need to find the sine inverse. And the sine inverse of 1 over root 2 is giving me in radians 1 over 4 pi. So I've set my calculator there to radians because it's dealing with pi in the formula. Now to get t on its own, I'm basically just dividing both sides by 120 pi. So that's 1 over 4 pi divided by 120 pi, which simplifies to t equals 1 over 480, and it's talking seconds. So that's my answer, 1 over 480 seconds. Again, just be careful there with your calculator. This part here might sound a little bit difficult, but just use your knowledge there of brackets. You can call it 0.25 pi if you want, instead of working to fractions. And the final part, V. Find a rate of change of voltage when t is equal to 2 seconds. Rate of change there, first of all, should be drawing your attention to calculus and differentiation. So we need to find the derivative of our function. So let's just first of all put back down our formula for the function, which is written as 110 root 2 sine 120 pi times t. Now it's in terms of t, and I need to differentiate this using the chain rule. So the derivative of v for t is going to give me 110. So we write our constant 110 root 2 again. Differentiate sine is written as cos 120 pi times t, and I times that then by the derivative of what's inside the bracket, which is going to give me what, 120 pi. So I'm finding the derivative of 120 pi times t. Sorry, it's not dx, it's going to be for dt, isn't it? Because we're differentiating with respect to t. So that's 110 root 2 cos 120 pi times t, and differentiating 120 pi t is 120 pi. So that's my derivative of my function. Now the question that was asking me to solve that for t equals 2 seconds. So we're going to let t equals 2 in this case, which is going to give me, subbing in 2 for t, so 110 root 2 times cos of 120 pi. Again, just use brackets here just on your calculator to be sure it works out for you, multiplied by 120 pi. Set your calculator in radians as well. We don't want to be in degrees because it's in terms of pi. So 58646.05. So what's that? It's asking us to the nearest unit. So that's 58,646 volts. What, per second? It's talking about volts in seconds. So 58,646 volts per second is the rate of change when time is at 2 seconds. Okay, that is question 9 complete. So question 10a part 1, the first part there tells us that 8% of the population have O negative blood type. Part 1 says that a blood donation clinic, 10 donors are giving blood. Find the probability that the 10th person is the third O negative donor. So that means that the previous 9 people that give blood, 2 of them must be O negative. And it doesn't matter where those 2 are. It could be the first 2, it could be the 7th and 8th. It doesn't matter as long as they're in that first 9 group of people. So what we're looking at here is the binomial theorem. There's success and failure, O negative blood type, or they're not O negative blood type. So using our binomial theorem, we have 9 people to choose from. Again, there's only 9 because the 10th person has to be O negative, and we'll worry about the 10th person in a second. But of those 9, 2 of them must be O negative. And the probability of getting an O negative person is 8%, which is 8 out of 100 or 0.08, whatever way you want to write it. And 2 of them are O negative. So that's my probability of success. And my probability of failure, i.e. not O negative, is 92%, or 92 over 100, or 0.92. And that's the remaining 7 people. And what I'm going to do to that then is, that's the first 9 people. I'm then going to multiply that by the probability of the 10th person being O negative. And the probability of that happening is 8 out of 100, or 0.08, or 8% basically. So I'm including the first 9 people here, and then the 10th person here, because that one must be O negative. And when I multiply that out on my calculator, I'm getting a decimal of 4 decimal places at once, so 0.0103. That's my answer to 4 decimal points. Looking at part 2 to that question, at a blood donation clinic, 5 donors give blood. What is the probability that at least one of the 5 donors donates O negative blood? Okay, so the key there is the at least phrase. Now we could go through each of these separately. We could find the probability of 1, or the probability of 2, or the probability of 3, or the probability of 4, and add them together. But it could be easier if we just look at the at least one part, and the key for that is that if we find the probability of none of them being O negative and subtract that then from 1, that will give us the probability of at least one of them being O negative. So we're doing the opposite basically. And in order to do that, I'm going 1 subtract the probability of none of them, well, what's the probability of the none of them? So it's 92% would be not O negative. So that's 92 out of 100 or 0.92. And it has to happen 5 times for none of them. So I would be putting that to the power of 5 because I want 5 of them not to be O negative there. So that would give me 1 subtract 0.65908, which is 0.340918, and again the question wants it to 4 decimal points again, which would be 0.3409. So that's the probability of at least one of them being O negative. Part 3 to that question is using similar information. It wants us to find the minimum number of blood donors required so that the probability that at least one of them is O negative is greater than 0.97. So if you want to scroll back up there or rewind to part 2, you'll notice that it took, 5 donors gave us roughly 0.34%. So I'm basically using the same piece of information. I'm going, because it says at least one of them, so that's my 1 minus my 92 over 100. But what I don't know this time is the power. I don't know the power, and that's what I need to find. And the question says at least one of them is greater than 0.97. So I'm just going to use my greater than symbol, 0.97. So let's turn them all to decimals since they've given us the 0.97. So 1 minus 0.92 to the power of x, some unknown power, is greater than 0.97. I'm going to subtract 1 from both sides, or basically move over that 1, which will give me negative 0.92 to the power of x is greater than 0.97 subtract 1. So that's giving me minus 0.92 to the power of x greater than 0.97 subtract 1 is negative 0.03. You'll notice here I have a negative on both sides, so we can change the signs, or in other words, divide across both sides by a minus. And just remember with inequalities, when we divide by a minus, we must change the direction of our inequality sign. So here I'm changing the signs, so I must change the inequality as well. Now I'm going to page 21 in my log tables, and I'm using the right-hand corner piece of information. A to the x is equal to y implies log of the base a y is equal to x. So I'm using that piece of information now in order to solve for my power x. And if I fill that in, my base a is 0.92 and my y is my 0.03. And that's equal to my x, and my x is my power. Yeah, I'm right with that. We've called it x. So it doesn't matter what letter you called your power. Going to my calculator and typing in that into my calculator gives me 42.05 as my value for x. Now the question wants us to find what's the minimum number of blood donors. Just be careful, your answer there is not 42. Your answer is 43 donors. Because 42, if I subbed in 42 as my power there, I would get a value which is less than 0.97. 43 is the nearest whole number. That gives me a value greater than 0.97. Obviously, we can't have a decimal as a donor number. That's why we have to round it up. So logic there tells us it's 43, not the mathematics to tell us it's 42. Okay. Part B to that question, so it's different now. We've finished part A, those 3 parts were linked. B is completely different. So B is saying a homeowner has a problem with the heating system in her house. A plumber has identified the problem as a faulty part. The house owner knows that in 80% of cases, a repair of the part will fix the problem with a repair cost of €70. If the repair does not work, then a new part will have to be bought costing €150, and there's an additional labour cost of €80 to replace the old part with the new. Find the expected value of the cost of fixing the faulty system. So it's a text-heavy question there, but I don't think there's too much to it. So let's look at the first part. If we focus in on the initial repair, which costs €70, and in 80% of the time it's going to be fixed. So that is 80% is 0.8 when I divide it by 100, and I multiply that by my €70. So expected value is found by just multiplying the value by the probability of it happening. But I now need to focus in on the part about the issue where the repair does not work. So if the repair does not work, she has to spend €150 on the new part and €80 on the call out for replacing it. So I need to look at the €150 and I need to look at the €80. Now they're not going to be multiplied by 80% because we're only looking at if it's opposite, which would be the 20%. This is when the part which was fixed did work. So the question says 80% of cases are fixed. So we're looking at the 20% which are not fixed. So that's why we're only multiplying these by 0.02, because this is the 20% of the time that the old part cannot be fixed when we need to replace it. So just to clarify, this part here is the fixed, and this part here is the replaced when it's not fixed. And it's not fixed 20% of the time, and it is fixed 80% of the time. And when I type that into my calculator, add them together, I'm getting an expected value of €102. So that's part B. Part C, again, is completely different. It's talking about a policy. So it's text heavy here again, so you just read it yourself first of all. But what it's going through here is €120 is paid out if person dies, 40,000 if they become disabled. The insurance company have found out, so let's link these together. So 120,000 if you die, probability of dying 0.001. So let's find that expected value. So that's 120,000 multiplied by 0.0001, which is €12. So basically in every policy, €12 must be set aside for the likelihood of someone dying. Then we have the 40,000 if you become disabled, and the probability of becoming disabled is 0.002. So let's find that expected value. So we have 40,000 multiplied by 0.002, which is €80. So €80 must be set aside for someone becoming disabled. If we add them together, we get a €92. That €92 basically stands for the average payout per customer. So in each customer's policy, €92 has to be set aside for paying out. Let's multiply that now by 18,000 because we have 18,000 policyholders. So I want to find out what's the total amount of money that this insurance company has to pay out. So when I multiply that, I get 1656000. So counting back three. So that's 1,656,000. That's the expected payout. Now we don't need to write this down each time. Like, you don't need to write down expected payout and so on. That's just to show you what we're basically figuring out here as we go along. Now they want to make a profit of €900,000. So we need to add on 900,000 to this to actually calculate the total amount of money that this insurance company needs. So that's 2,556,000. So that's how much money they need to make in order to make a profit of €900,000 and pay out all those claims. Now we want to find the annual premium per customer. So in order to get per customer, we need to divide the total pot of money by how many customers they have. Well, they have 18,000 customers. And when I divide that by 18,000, I get €142. So the average premium that this company should charge is €142. And that is question 10.